Hello everyone, this is Professor Johnson, and in this video I'm going to reveal the solutions to the POCTF, the Pointer Overflow CTF Challenge in 2024. And in this video I'm going to talk about the exploit challenges. If you're here looking for solutions to the 2024 challenge, I thank you so much for your patience. I apologize for the delay in getting these out. And I'm glad that you were willing to come back and try and get those solutions. In this video, I'm going to cover exploit challenges up to the final 300 level challenge. If you want the solution for the 400 level challenge, check out the 400 level video that I put out a long time ago. We will begin with exploit. I'm going to hide these columns. Keep coming back. There we go. Exploit 100, a finer token never was. This is a simple exploit challenge for you. Here's a little bit of a twist to make sure it's not too easy, but it's otherwise a straightforward challenge. I give you the targets, and I give you the source code, exploit 100-C, and I give you well, is that supposed to be the route, or I'm sorry, it's been a while since I put these together. Some of them I'm just genuinely not remembering how the challenges went. I'm gonna need my solution, I'm sure. Oh, that's the binary, right? Provide you with a source code and a copy of the binary locally. So if you run the binary, maybe I should pull up my VM for this. Yeah, I probably should. Well, that's not in the cards. That's not in the cards. I already have a VM running that is working on other things. So we'll just have to deal with what we do have, which is the source code and my solution. All right, so very simple source code here. There is a function that pops a shell. Here's our vulnerable function. We declare a buffer. We request the number of elephants. We request the number of elements. Then we just have a scanf, gathering user input. Then we enter the elements, and then we have a for loop to iterate through the elements. This is vulnerable, a simple buffer overflow. So head to the pop shell function. There you go, and you'll get yourself a shell. Something like this here in my solution. So we, first of all, I use the local version. This is a non-position independent executable. There's no ASLR. So we get the address here from our local binary and get where we want to go. We can confirm all of this with GDB. We can get a local version working, no problem. Figure out our offset, which in this case is 64, then plus 8. Then we drop in our return address. Excuse me. 64 plus 8 for the base pointer, and then our return address. Then that takes us up to we have to play ball here with the application. Then we send our payload down here. It calls the pop shell address, and there you go. We get our shell. Exploit 100 heroes and zeros. This one, I created a little game. This one was kind of a prototype for the 2025 category of game hacking, which, I mean, I've basically I've gotten rid of crack as a category, and I've added game hacking But to be honest with you, game hacking is just another type of exploit challenge. So I haven't completely figured out how that's going to work. I think what I'm going to do is I'm just going to get rid of the crack category so that there's 8 categories in the contest. Make every category slightly longer to compensate for the lesser number of challenges total. There were 90 challenges in this contest. I'm shooting for 100 in 2025, so we'll have 8 categories, 100 challenges, and I'll just add to the exploit category with the game hacking challenges. Because this one was kind of fun, I guess. So yeah, it's just a little game. You download it, you play it. You have to hack the game to win. There's a couple of very easy ways to get it. You can simply save the game and edit your save file. You can edit running memory while the game is going, or you can just decompile and look through the source code. And you'll find the flag. So you have to make your number of PowerPoints 10,000. That was it. A very simple game hacking challenge, but this is something different. Exploit 100, smack stashing. So yes, here I talk about the article by Elf1, the stack smashing article, I think. Yes. And so I provide you with a binary that basically recreates that scenario from way back then. You know, and just like back then, there's no protections really at all on it. So no dep NX, no ASLR or anything. Here we go. Oh, come on. All right. I even identify in the source code where the vulnerable function is. We have a gets with no bounds checking. So we have a shell function. This is a lot like the other exploit challenge. And as a matter of fact, it's even easier than the other exploit challenge because there's no weird interactivity or menus or anything. God damn it. So my solution. Simple as this. Again, you just find the address of the function you want to call, calculate your offset, which can easily be done in a debugger, send the payload, which is your offset plus the shell address. The offset is going to mean everything that's been allocated for the buffer variable plus 8 bytes for the base pointer. Then you're at the return address. You then replace the return address with the address you want to return to, and there you go. It's a very simple process. Okay, next we have exploit 200, make of it what you will. I don't know why we're looking at it like this. It's not binary data. What are you doing? Oh, because I put binary into this challenge. That's why. Or is no, that's not it. I don't know why DB browser is being kind of wiggy with this one, but that's fine. We'll get through it. Can we? Nope. It said binary information can't be viewed in this mode. So weird. Anyway, when I was introduced to the subject of software exploits, it's always amazed me just how one tiny little mistake could lead to complete disaster. Etc. etc. Spaghetti code. Is this the one that I did in... Nope, this one's in C2. So we have this source code. We again have a shell function. We have a buffer variable, enter some text. Then we have a gets and then buffer. Is this just another... Did I do this multiple times? No, I'm still looking at smack stashing. That explains it. This is make of it what you will, which is this. All right, so for this one, oh, right, this one. Oh, this was a good one. Right. All right, so this one is a format string error. So what the source code here does is it dumps the flag into volatile memory, and then the program itself prompts you, says welcome, whatever you enter, and then it spits it back out. So if you mess with the input there and take into account that there's no input validation or anything on the input, you can read back parameters in memory, including the flag that's in volatile memory. To get this one, I'm trying to remember which position it would be in. I believe it was, well, let me check my solution. That will tell me how far it was. Let's see. Hex 2F, base address plus or minus hex 2F. So that is where you would find it. Exploit 200 overrun and outdone. Oh yeah, this is when I created that incredibly annoying helper app. Let's figure out how to access them. Okay, yes. I remember this one. So here's the source code. So there's a guest ID and a root ID. The name of the game is to buffer overflow, not to target an address, but to change the ID number from 101 to 885. So here's where you get your menu. The menu allows you to rename yourself. This one allows you to become an admin account. Access debug mode, so to pop a shell, and then quit. New name, how exciting. Then you get a chance to input the u.name attribute. Then if you choose the admin account, it actually does nothing. It just gives you a print statement. Choice 3, I'm sorry, it's the allergies. If you're still a guest, which it gets if the u.id attribute equals the guest ID, guests aren't allowed to use this feature tee, but if you are the admin account, then it does indeed pop a shell. I don't know what kind of user you are, so mysterious, if it's anything but the guest ID or root ID. Then an annoying message if you exit, and if you print anything else, then that's not an option. Okay, so again, you just have to enter the u.name attribute, overflow that attribute to the adjacent attribute until you get to the ID attribute, change 101 to 885, and you're good to go. 200 to finish and flounder. Might be the company I keep, but I rarely see a good old bin patch challenge in CTFs these days. Might be because they tend to be a bit on the simple side every morning after the preamble and jump to wherever they work that day, etc., etc. So I give you an exe file on this one. Cucksum. I don't remember if I did that on purpose or not. Let's see what we got, though. Okay. I don't know if that's current. Well, let me see. Oh, I think this is the one that also created some problems for people. If you look at the source code, here, there's the key bin, which was downloadable. Here's the encrypted flag. So all you had to do is work out the secret password by deconstructing, excuse me, the XOR function here. So it was really as simple as that. I don't think this one caused too many problems. Certainly one of them did. Exploit 300 Empress of what? Oh, this one's just the ROP chain challenge. So yeah, construct a ROP chain and you get the secret cookie. Here's my solution here. Let's see. Or was this a return to loop C challenge? Yep. So here's my chain. There's a pop RDI return, overflow, then pop RDI return, RDI, bin shell, syscall, and then you're done. Exploit 300, the trash heap has spoken. This was a line from Fraggle Rock. Same for an Oregon Trail. In fact, I think it's I'll work on it myself. Make a mint. Here's my first prototype. It's got a long way to go. Oh, right, this is this one. This one here. So you start. It's a mini expedition type thing. You can get a debug shell to get your shell. Treasure found. Unfolding the map, plotting the course. My to-do list here. What tool will you bring on the expedition? Who will join the expedition? And so on and so forth. Welcome all the explorers, and then it pretty much does that, right? Welcome to the treasure hunt, and then it dies. It's not yet complete, of course, but here's my solution. It's much more simple than it appears at first blush here. So welcome to the treasure hunt. Enter an explorer name. You do your overflow there, so you input your payload. When you get to the tools, then you send a second payload that's going to be the offset from the tool to the return for that. And then when you call to play the game, it will eventually call the tool, which will call the return, and then you get the shell. Last one, Watchful Heavens Waiting. This was actually legitimately almost the 400 level challenge, but I decided to swap it out because I wanted the 400 level challenge to be doable. And I mostly was concerned because I haven't done any exploit challenges like this in the past. I know that this is common in other CTF challenges, but I've never personally messed with it. So instead of creating a remote target to pwn, I actually give you what you need to source a VM and compromise the VM itself. So there's a service running on it that you have to compromise. The source code itself it's just out there. It's listening, and you can send it data. And when you decompile it, send the right data. Leak the kernel address, then you can get the flag, which is an environment variable, a system level variable. Okay, so that's it for the exploit challenges. We've still got miscellaneous OSINT, reverse, Stago, and web to go. So I'm moving on to the miscellaneous challenges. If you're going to go over there, then I will see you there.